Hi everyone. Today we're going to study the fundamental theorem of arithmetic. Every composite number can be expressed, or we say factorized, as a product of primes. And this factorization is unique, apart from the order in which the prime factors occur. That is, given any composite number, there is one and only one way to write it as a product of primes, as long as we are not particular about the order in which the primes occur. In general, given a composite number x, we factorize it as x equals p sub 1 times p sub 2 times up to p sub n, where p sub 1, p sub 2, up to p sub n are primes, and written in ascending order. If we combine the same primes, we will get powers of primes. Example, we have this number, 32,760. We can factorize it into like this. We have 2 times 2 times 2 times 3 times 3 times 5 times 7 times 13. We have the prime factors here. Then we combine all prime factors which are same. We can see here that the factor 2 appears 3 times. So we can write 2 cubed times the factor 3 appears twice. So we write here 3 squared. Then we just copy the 5, the 7, and 13. The expression of a number into product of prime factors is called prime factorization method. Example 1. Consider the numbers 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with a digit 0. If the number 4 raised to n for any n were to end with a digit 0, then it would be divisible by 5. That is, the prime factorization of 4 raised to n would contain the prime 5. This is not possible because this 4 raised to n we can express as 2 squared that is raised to power n. Then we multiply the power 2 by the n. We have now 2 raised to 2n. So the only prime in the factorization of 4 raised to n is 2. So the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 4 raised to n. So there is no natural number n for which 4 raised to n ends with a digit 0. Example 2. Find the LCM and HCF of 6 and 20 by the prime factorization method. Let us write the two numbers 6 and 20. Then we factorize by prime factors. For number 6, we have 2 times 3. For number 20, we have 2 times 2 times 5. We combine the 2 and 2 using powers. We have now 2 squared times 5. Then we have the HCF, which is the highest common factor. By definition, we say that HCF is the product of the smallest power of each common prime factor in the numbers. Looking at the prime factors of 6 and 20, we can see that the common prime factor is the number 2. But based on the definition, we will take the smallest power. So the HCF of 6 and 20 is 2 with power 1. HCF is 2. Then we go to LCM. LCM means least common multiple. By definition, we say that LCM is the product of the greatest power of each prime factor involved in the numbers. So for LCM of 6 and 20, we're going to copy all the factors in here to be multiplied together. In case of common factor, we will take the greatest power. So we write here 2 square with 2 as common, and we take the greatest power or greater power. Then we write the factor 3 here. Then we copy the factor 5. We get the product. The answer is 60. This is the LCM. Example 3. Find the HCF and LCM of the numbers 6, 72, and 120 using the prime factorization method. We write the three numbers in here. Then we write the corresponding prime factors. For number 6, we have the 2 by 3. For 72, we write 2 cubed times 3 square. For 120, the answer is 2 cubed times 3 times 5. Now let's begin with HCF of the three numbers. We define this HCF, the product of the smallest power of each common prime factor in the numbers. Looking at the prime factors, we can see that number 2 is common, but we will take the smallest power, and that is power 1, to be multiplied by another common factor, which is 3, and we take the smallest power, which is power 1. So this is 2 times 3. HCF is 6. Then we go to LCM of the three numbers. Again, we define LCM as the product of the greatest power of each prime factor involved in the numbers. We will copy all the factors in here. We will write as LCM. So we have 2 cubed. This time, we will write the highest or greatest power times the 3 with power 2 times the factor 5. When we simplify by getting the product, the answer is 360.